Sound 1. Introduction. What is sound? Sound is a sensation that is always all around us. We hear sounds when objects strike or any disturbance suddenly happens in the air. But if we close our ears, we cannot hear any sound. Sounds are of different kinds. Some sounds are loud, other sounds are low or soft. Some sounds have a higher pitch. A scream is at a higher pitch. Girls have a higher pitch of sound than boys. We know and understand pitch directly by our sensation of it. That is, we can directly know what is at a higher pitch and what is at a lower pitch. Gradation of pitch is, after all, the musical notes sa, re, ga, ma, pa, dha, ni. Sounds coming from far are heard faintly, and those coming from near are heard more clearly. There is also a quality of a sound. We can recognize our friend's voice by the quality of his voice. Now, these facts seem straightforward, but they are actually wondrous facts in nature. They actually raise many questions. We normally do not ask these questions because we take these facts for granted, having got used to them from childhood. We feel they are like that because they are like that. But these facts suggest many deep questions. What is sound? This question means that what is happening really between the source of the sound and our ear. When we clap our hands, for example, we hear a distinct sound. But the real question is, what happened quickly between the point of clapping and our ear? It is a wonder that something happens, isn't it? What is it? To put the question in another way, what is the physical basis of our sensation of sound? The next deep question that can be asked about the facts given before is, when is a sound heard loudly and when softly? The third question that can be asked is, when is the pitch high and when is the pitch low? You see, something invisible is happening between the source of the sound and our ear. What is it? Let us now proceed to answer this question. The ancients asked these same questions and suspected that air has something to do with propagation of sound. There is a famous bell jar experiment that can be done. Take a jar and put a bell with connection in it. When the top is not sealed and the switch is on, the bell rings and we can hear the ringing of the bell. Now, remove the air inside the bell using a vacuum pump and seal the top. Again, put the switch on. We see the bell shaking, that is ringing, but we don't hear anything. Yes, air is a part of the process of transmission of sound to the ear in the atmosphere. But the question still remains, what is the role that air is playing? What happens to the air? In the 10th century, a remarkable fact came into light that an inch of any material, solid, liquid or gas, is made up of crores and crores of atoms or combination of atoms called molecules. Keeping this in mind, it is obvious that something internal is happening that causes the disturbance that reaches our ear and causes in us the sensation of sound. One can understand this by realizing that sound propagation is invisible and something must be happening inside and in the air. Now, the gases in a region or liquid or a solid contain atoms, molecules in close proximity. They are close to each other. Of course, they are closer in solids than in liquids and closer in liquids than in gases, but atoms are close. Now, atoms when brought together have the property of elasticity. They are like balls with springs attached in the middle. When we shout, let's say, or two things strike, the molecules immediately beside the source gets disturbed and gets compressed. But since the molecules are connected like springs and are elastic, they snap back. But in going back to their original position, they do not come back exactly to the original position, but go an extra distance. This pushes the next immediate air, that gets compressed, and that too tries to come back to its original position and goes an extra distance and compresses the next immediate air, and so on. A wave of compression, more pressure, and what is called rarefaction, less pressure, molecules more apart, occur. The above is only for one hit of the source, but the source is continuously giving pressure, so a series of waves is sent out as long as the source has vibrated. The wave travels out and it is energy, and due to the pressure increase, loses ultimately its energy due to getting converted to heat. Hence, we cannot hear sounds or only very faintly at a distance. So that completes sound 1. We have understood in this module what is a sound. It's a compression and rarefaction of molecules of air or any other medium. Sound can travel even in solids and liquids. So I hope you enjoyed the show. Thank you. In the next section, we will see how pitch and loudness depends upon frequency and amplitude, two concepts of sound. Okay. So thank you. We will meet again in sound 2.